we want to hear about it. Yes. You will be in the community. Yes. So basically, it's not based on your past glory or your title. It's basically who you are and how much you bring to the community. And everyone is welcome. Doesn't matter the stack, doesn't matter the race, doesn't matter the gender. We are very open. Age, we have very young Padawan here who is even 14 years old. Yes. So yeah. So we welcome everyone, and we want to be the place which is, welcome to everyone. Everybody feels good in this place. So now is and we want to reward our members by contributions they put into the community. So today I have 3 rewards. Roshni contribution was finally, she joined at the start, and this little logo, everything is actually her doing. So as a little thank you for you. I don't know, we should hug, okay, hug. Second one, I'm really bad at this, so sorry. Wojtek, where is Wojtek? Wojtek as well. We worked together in our previous life as well. So Wojtek is guy behind the camera. So every picture is recording is Wojtek's doing.
Thanks.
That's for you as well.
Thank you.
And it's not much, but I really like the cups. I'm so proud of the design. It looks very good. So even for the cups, just contribute. And where is Dmitry? Dmitry is not here because he is busy, and that's why he's got his prize as well, which I give him later. So this event today is happening thanks to Dmitry, who is working in TEIA, and he is behind syncing, organizing everything today. So we have this lovely venue on our disposal. Whoa! If I don't break anything, so sorry. Yeah, and how actually you can contribute to our community, how to support us, join our events, which you already do, which we are grateful for. The second thing, as we are quite a new community, please spread the word about our community. Yes, my network or the people who are more engaged, they already know about us, but we want to reach more people. And in one of the last posts, I say, you are our best ambassadors. Yes, if you like it, just share that with your peers. Yes, with your coworkers, social network, and other. And also financially, donate. You can donate on opencollective.com, which actually, I don't know about the time, so maybe not today. Yeah, so it's basically buy a coffee. Yes, for example, I donate £10 per month, but that, if let's say 10 people donate £10 a month, that is 100. Yes, and one of the problems, for example, now we have is with venues. Yes, if we have our own budget, we can go to the commercial venues and hire them. Yes, right now we have to rely on companies like TEIA who want to host us for free. So this money give a freedom. That's easy to say, and there is a lot of truth with this. Yes, where you can find us. If you want to make picture, I won't talk about this one. All the other links you can find on website as well. So this is where we talking about. Discord is quite good to join, where we discuss day-to-day thinking about the community, share interesting links. We have bi-weekly meetings about what is going on in the community, stuff like that. So Discord is most of the where if you want to be more engaged is good to be. The other side, we just share about interesting links about the community again. So we will appreciate if you follow us, if you share our posts, like it, whatever. You know, the whole world is now on internet, yes, and we have to be there as well. And I forgot one thing, but I fixed that at the break. So, and meetups, yeah, again, coming back to the sentence is community for community, and speakers are part of the community as well. So if you have anything interesting to talk, doesn't have to be great, doesn't have to be, you know, innovative, it's something you work out, you don't have to be experienced speaker, just submit your session, and actually that's how this event hub started, yes. We want to give the opportunity for not the Java champions, yes, to have opportunity to talk as well. Somewhere you have to start, yes. And many people, including me, we just start with this local user groups, yes. So again, we were in London Java community. London Java community was very well known for creating now like Java stars, yes. And I want to replicate kind of like the same thing here. So these are community events. Again, organized. We would like to organize them every month, but again, we struggle with venues. And yeah, even if you are, so hello to the all who are online. If you cannot attend, we always stream those events on Wojtek's channel, DevTalkPlanet, where I want to say something else. Yeah, so basically, this is also like our way to help speakers, like if they can review, they talk at the recording, yes, what they're doing wrong. For example, I learn this way, yes, I just record my talks. I hate it, but I learned this, like, okay, you did this wrong, yes, you did that wrong, yes. So yeah, everyone is welcome, and I don't promise you we speak next month, but eventually you will. Sometimes I speak with speakers for a year before we actually synchronize and they are able to join our meetups. And this one I would change that. So we have today one IntelliJ license to as a giveaway. In the break, I will provide new QR code because this one I forgot to change. I was too busy to speaking with people that I forgot to change. So basically, there is latest post on LinkedIn. Just like it, share it, and then at the end we will select one person from those who liked it or interact with it to win the. Withdraw, not select, withdraw. One person to actually get the license free. It's a 1 year. Even if you have your license already, private license, you can add it and it basically extend for another year. So it's not like even if you have a license, you think, I won't take part. It is, for example, for me, myself, I received one and it was, I have already license, it extend for 2 years. Yes. So, and that's all from me. I'm around if you want to ask about anything, just I will be here. And now I will give it to Molly.
Because we want a speaker, and not only for some idea. If you don't feel comfortable on the stage, you can contact with me. I give you an interview, for example, and you can try recording your presentation, and you can make it like a post-production and put on my YouTube channel. You don't need everything in your hands. I can help you. Okay. Thank you so much.
Okay. So about this, you can speak with Wojtek. Is like we try to run it like if you have idea, you are responsible for that idea. Wojtek just have this one and he takes the lead. So that's how we operate as well. Yes, I don't see Molly from there. because she should give like introduction to Taya. I can talk more, but I don't know if you wanna hear me. So maybe Martin, you will speak first. Yeah. So let's see. Let's connect because I don't think Molly will have slides, but we can prepare.
Yeah. Cool. So, hey everyone. I'm going to be talking about event storming. I'm going to start with a few kind of theoretical things. So hopefully it's not going to be too boring. Before that, I'm Martin. I'm a software engineer. I've been a product manager as well, consultant. Those are some of the places I've worked at. And most recently, I've been working at Argos. For the past few years, I've been sort of interested in what it means to have a high-performing team culture, high-performing sort of delivery system for software engineering. And this is what led me down the rabbit hole of topics like event storming. I have this sort of naive idea that maybe if I share more about these things and people kind of spread the word about these practices, maybe there's going to be an uplift in the quality of engineering that we do in our jobs. So I want to start with a rather naive, sort of almost silly question. What's the goal of software engineering? I love these questions because often they have a lot of nuance, there's a lot of debate, and they can bring out the real fundamentals of something. So you can say maybe it's writing code, but to me, this is just the artifact that we produce. It's just the output of our work. And if I were to compare it to something else, to me, it feels like saying football is just about kicking a ball. It's not just that, because it's there are all of these other processes that are higher level on top of everything else, kind of like collaboration, the strategy, the tactics, all of that stuff. You can say it's about shipping features, but I wouldn't say that's quite there yet as well. There are a lot of features that get shipped that don't end up being used, a lot of products that don't get used, and so on. I really hope nobody answers this. So what would you guys say? What's the goal of our profession, software engineering? Yeah?
Satisfy the product.
Yeah, good answer. I like that. I think that's pretty much what I would say as well. We turn this into that. We have some sort of real world process, which is exchanging money, for example. By the way, this is total coincidence that Taya does payment related stuff. But essentially, we have some sort of real world process. We have some business transaction, some sort of concept, a bunch of users, and we encode this into software. We produce a software which runs and serves some sort of need for a customer, whether that's you're banking or scrolling cat videos on Instagram. It's fulfilling some sort of need for the user. But there's a thing. Everyone sees the world in a different way. And I'm sure you've seen one of these things where it essentially shows how people view reality from different lens, right? Everybody sees their own corner of the universe and not necessarily the full picture. And that's exactly the case with software. This is some sort of payment service where you have your account object with a bunch of different methods like credit and debit. You have your payment service which facilitates this. This is essentially semantically the same piece of code facilitating a transaction, a transfer, but the sort of responsibilities are inverted in a way. You have a transfer object which executes some sort of action on two different accounts, and it governs the rules of how the transaction should happen. This is a real piece of code that I've seen. It's actually a screenshot, and it shows another type of way of looking at reality from a different angle. Those are two pieces of code from two different services, which should ideally map to one another. My task was to map from one to the other, and at first I was really confused because it made no sense. We have promotion type, discount, voucher, and code. How the hell do I map this to single-use coupon, multi-buy, multi-use coupon, or generic? To me, those are not the same thing. It made no sense. Another type of viewing reality from different angles. Let's say we have a meetup talk, such as the one that we have here right now. You can have a proposal for a meetup talk. You can have a schedule, you can have speakers, you can have rating, you can have it filmed and posted on YouTube. And those are not necessarily the same things. Sure, they are part of the same sort of process, the same domain. But if you were to have, let's say, one giant table with all of these things, you would have a model which is very bloated, and it would be a pain to deal with in a real-world application. Any sort of change would affect multiple other things, and it would be very difficult to work with. What I mean to say with all of this, when people view reality from a different angle, you get model choices that reflect this. And your model choices, by model, I mean what you encapsulate in your software code. You get different trade-offs. Your model will be wrong most of the time and right only some of the time. So this is all due to silos. Knowledge silos where different teams or different people accumulate only a part of what there is to know about a system. There's this guy, Melvin Conway, who came up with this observation. He observed that the design that gets produced from an organization is directly influenced by the communication patterns and the communication structure within a company. This is a real message that I've received. So it says, the original message broker flows were written a long time ago. No one is around who built it originally. The microservice was written to replace flows a while back. Those engineers have since left too. It's a very common scenario. There's a piece of code which someone wrote. They didn't necessarily share or spread the knowledge. And now nobody wants to deal with that. Everybody wants to just stay away from that part of your code base. This is another way of representing this whole thing, where some knowledge is shared. There's some sort of diverging opinion somewhere. Nobody knows about some portions. This is that previous slide here. One that I like is the Ask Bob circle. I swear that every company has this one person who knows, like, I don't know, 80% of the code base, or like a really niche part of the code base, and he's like the go-to person for a whole lot of stuff. And his time is just clogged with people asking him for knowledge that nobody else has. So this is one of my main points here. How, when, and what information gets shared within a company is one of the most crucial things in a software team. This is a direct consequence of having bad communication patterns. This is the information bottlenecks bingo. Outdated documentation is a classic one. Joining a new team. How do you get up to speed with a new product that you've just joined and there's been like maybe years of development? A lot of the times, at least some of the teams that I've joined, you need to speak with, I don't know, 10 different people just to understand one whole flow or process. Or another one that I like is, it happens very often, where you need to organize a meeting with someone, you prepare some questions, not all of them get answered, you then need to go back, you need to check a few more things, you need to organize another meeting in 5 days' time, and a simple change can grow in scope and drag over multiple weeks just to develop something. This is my main point here. It all comes down to feedback loops. It's a concept which is hopefully very intuitive, but imagine you have, you're in a cold room, and you have a radiator and a thermostat. But let's say your radiator is very good and your thermostat is very dumb. Let's say your thermostat can crank up the heat in like 5 minutes, but your thermostat only registers changes in temperature every 2 hours. By the time it registers its first measurement, you're going to be in a sauna, basically. And an obvious question here is, what does this have to do with software engineering? This is just an example of a feedback loop, but in software engineering, everything has to do with informational feedback loops. And those are some of the feedback loops that we have to deal with as software engineers. Is our product useful? Metrics like usage metrics for certain features, certain parts of the product, or revenue can indicate this. If you go one level deeper, you have your individual code metrics. Let's say, is my test doing its job? You verify this with tests. Does it perform well? You do your performance tests and so on. But the not so obvious informational feedback loops are, is my model good? Have I produced something which is resilient to change? How often do I need to change it? And those are the type of questions that make your model good or bad, as well as the shared understanding. Like, how many meetings do you need to go through? Yeah.
Sorry for disturbing, but we have some technical problems.
Yeah.
With the stream. Yes. Can I?
Yeah.
Can you go to the StreamYard? Because you're sharing the presentation as the present copy to present,
Right.
and the screen rather than, because it would work, but you have to change it. Yes, kind of like go here to present. No.
Here.
Yeah.
Here.
Present. Share screen. Share screen. Yeah. And what? Entire screen.
I thought I was doing the entire screen.
It happened to me as well. Yeah. Wojtek, you see?
How do I change it? Oh. Whoa. Full scope. We don't want full scope.
Go back again because something we didn't want to share screen. Maybe stop this one. Yes. Maybe you should stop. And it comes to yeah. And present. No. Entire screen. Because Wojtek.
Is it the correct one now? So, informational feedback loops about the model. Those are the types of questions that I am interested in because they're a bit more vague. But I think they reveal a lot about the model. And this is how you get into this type of mess sometimes, which is quite common in a lot of companies. You have a lot of silos, which increases the cost of consensus. You have this sort of fragmented knowledge scape. It's hard to make decisions. People are afraid of breaking things, and you get a clogged organization. So if there's anything that I would like to emphasize, it's this: having those feedback loops, sharing information about the model, constantly checking, is my model reflecting reality and how we expect our software to work? It's one of the most important questions in software engineering, in my view. And this is why we have event storming, finally getting to event storming. So this is Alberto Brandolini. He's an Italian developer who, off the back of the domain-driven design movement and event sourcing, not to be confused with event storming, came up with the concept of event storming, which is a workshop format. It doesn't solve all of the issues that I described previously, but it definitely can help with a lot of them. And what is it? It's a workshop format. So what I'm going to show you here, they are just guidelines. They're not strict rules for running a workshop with event storming. The aim is to develop shared understanding around the problem, around the model, around what it is that our software needs to be doing. The way to do this, it uses a very simple notation with sticky notes and just a blank canvas. To give you a good idea of how it looks, this is a physical event storm workshop. This is the sort of output you can expect. We have a lot of colorful sticky notes, which represent different parts of a system and different flows within a system. These are some of the sticky notes that you may use, and this is the basic notation which you're going to be able to learn now and be able to apply it tomorrow. The main sort of crucial part of event storming is the domain event sticky note, which is the orange one, the first one. It needs to be in past tense. It needs to represent something that both developers and the business can understand. And it represents a state transition. It doesn't necessarily need to be that you have an event-driven architecture system or anything to do with events and sending of events, nothing related to Kafka and stuff like this. You can treat those as just a state transition. You have the command notation, which is in imperative form. So it's when a system or a user is performing some sort of action, which would typically result in an event, or can not. It doesn't have to. We have the read/view. It's a sticky note which shows that there's some sort of information being relayed back to the user. Yellow sticky note is for a user, or maybe it could be another system performing an action. Pink one represents an external system, which you're not concerned about in the scope of your event storm session. So it could be some sort of external API, or if it's the scope of an individual team, maybe it's some other team's API that you're calling. Purple one represents some sort of hotspot or potential issue, maybe a potential opportunity for something that the team can work on. Problematic areas, questions, unknowns, that type of thing. How to run an event storm workshop. You basically have someone facilitate, you send out a bunch of invitations to relevant people. It's good to have representatives of multiple different teams that are relevant to the systems you're mapping, just because you need that sort of domain knowledge and you want to capture that. The way to do this, you start off with a single kind of like a brainstorming session almost, where everyone lists as many domain events about the system they can think of. They put them out on a board, and then they arrange them sequentially. From there, a lot of discussions can start. It's particularly the case with larger groups of in-person event storms, where You can get, let's say you have a group of 20 to 30 people, and those can easily break down into smaller subgroups where maybe there's an interesting discussion going on, maybe there's a debate of how exactly the system works, but those are the kinds of things that don't necessarily translate super well to an online session. You can still do it online as well. I've done it at work as well, where you can use breakout sessions to have those smaller group discussions. And it's also worth having someone narrate the whole story backwards as well, because sometimes when you start with the end state of some sort of user flow, you can easily discover things that you missed along the initial sequential way. It's good to have a round of just highlighting potential problems and opportunities. There's something called the arrow voting stage as well, where everyone sort of highlights the things that they are interested in as a topic of discussion. So now, to show you what the outcome of an event storm could look like. As I mentioned, I currently work at Argos, and this, it's not something that we've done together with my colleagues. I did this just as a mock-up for this session. It doesn't necessarily reflect exactly how our flow works, but it's just representative. Imagine you have a bunch of items added in your cart, and this sort of model currently represents the checkout flow. Those are the types of events you may list in your board. Delivery slot selected, payment added, and finally you would end on an order placed. The next step of your event storm session would be something like this, where you list everything sequentially, you arrange everything in the sequence that represents how the flow should work. This would be essentially what your customer sees, how they interact with your system. And this can literally read like timeline, almost like a story. People like stories. It's very easy to think in stories. So that's why this is a good way of representing the true state of your system. Here you can see I've represented external systems, which I don't care about at this stage, as pink sticky notes, like the order system or fulfillment system, which would be called. And finally, when we start adding a bit more detail, it would look something like this, where you have a user adding items to a cart, going to the basket page, and then starting the checkout journey. This vertical line here represents a good sort of cutoff point. And if you go down the route of like proper DDD modeling, this in itself could be a separate bounded context. This can be a bounded context, and so on. So once the checkout session gets started, you have some sort of orchestration service. This is the purple-ish sticky, which I don't think I mentioned on the previous slide. But essentially, we go into two different flows. We have a delivery journey and a collection journey, where a few slightly different things can happen. For example, the delivery journey, you need to select an address. The collection journey with Argos would be you get your items shipped to a physical store, so you don't need to, you select this beforehand. You don't need to necessarily go through that again. And once you've selected an address, you get presented with some sort of payments view where you add your payment card, and then you place the order with the place order command. Here, let's say you have some sort of concurrency issue with adding payment methods to your session. You can highlight this, and this could be a topic of conversation. You can dig deeper into it afterwards with all of the discussions that you would have with your colleagues. And then this can be your cutoff point. After that, you pass on everything to your order system, and depending on the scope of your event storm, this is the output. This also can double up as a documentation as well. So, which is why I mentioned joining a new team can be very beneficial with something like this, where a new team member can easily sort of see at a high level what the system is doing, when it's doing it, and so on. So, going back to this, those are the key points that I wanted to highlight. It encourages collaboration. By seeing those flows laid out, a lot of people may notice things that maybe should not be the way that they are, or you just get to talk about the process, the states of your system, and so on. And it really bridges the gap between product people and tech people. Software engineers, they care about things like databases, Redis, Postgres, and so on. Product people wouldn't necessarily care about this. But by doing an event storm session, you bridge that gap and you talk about the problem that you're modeling, in facilitating those conversations. It's a collaborative problem discovery tool. And it also reduces those feedback loops that I mentioned, where instead of going back and forth with multiple different teams, product people, software engineers from other teams, and so on, you get to sit together and have the conversation, map out the system, and find some of those unknowns much quicker. There are a few different formats that you can do with event storming, and the orange sticky, which is the domain event, is the common thread among all of them. The big picture event storm, it basically aims to represent a full system. So this one, it can you can spend a lot of time, maybe even multiple days, just mapping out an existing system, or if you're discovering a new system, trying to plan for how you're going to build it. It can take a long time because most real-world software can be quite complex. During a big picture event storm, you would focus on the more high-level pieces like systems, actors, maybe hotspots in the system. Then you drill down to individual processes. At this point, you care about the commands and read models. If you want to get even closer to the code, you can do that as well with an event storm session. This is where doing like proper event sourcing and domain-driven design can be really beneficial, because it helps you sort of find those aggregates and the domain events. I mean, you've already laid them out on the board itself. By the way, I've even seen a Miro plugin which takes the event storm output from Miro, and it generates code with I think it's the Axon framework. So it was just a cool thing that I saw. You can literally generate code with a Miro board. Not necessarily best practice, but these are some extra resources. I'm happy to share the slides afterwards. But introducing event storming is the book by Alberto Brandolini, who came up with the concept. It's not 100% finished. That's why it's on LeanPub, but it's still a very good resource if you want to dig deeper into this. There's a Miro template and a Figma template, which can get you started with event storming sessions. Event modeling, it's kind of like an extension with a few more rules and guidelines on how to model a system. And event storming DDD talk, this is again by Alberto Brandolini on one of the conferences that he's attended. So before we get into any questions, I wanted to mention I do want to start offering some sort of consulting service, which is to help product engineering teams to adopt some of those practices that reduce the feedback loops. My main offer right now is the idea to essentially do 4 to 6 weeks of a sort of part-time work to discover bottlenecks, basically analyze the delivery pipeline within the company, and produce some sort of roadmap on how to improve that. I am going to have limited time because next month I have a very important release date, which is the birth of my first kid. And I'm not going to be able to do more than 1 or 2 clients at a time in the near future. So happy to keep in touch and talk about stuff like this. I do have like a quiz assessment thing in my website, which basically gives you a quick sort of score of delivery practices within a company. I've also got links to my LinkedIn if anyone wants to connect. So yes, that's all. Thank you so much. I'm happy to answer any questions. Yep. So yeah, that's a big question, right? So I think there are many feedback loops to introduce. Sharing information is one of them, which is why I think practices like event storming are useful. Being able to deploy code as quickly as possible and test it out as quickly as possible is very crucial. So having good CI/CD pipelines, feature flagging to be able to roll out a change, I don't know, in the next few hours or a few days instead of in the next few weeks. This introduces a feedback loop where you can release code, uh, release it to a few users or a subset of users and see if it does anything. You can see if your design is right by doing so as well. Maybe you didn't think about a particular flow, which is very crucial. Maybe, yeah, there are all sorts of things that come from doing these things iteratively in small batches. So small batches and frequent communication. Those are my top two. Ravi. You could, I mean, I think you can try to update it as a documentation, but in my experience, people don't like updating documentation. Although with something like this, I would like to think that it's much easier to update because it's literally just sticky notes. And if you have it in Miro, it's not too difficult to rearrange things, right? So, yeah. Joseph? Mhm. Mhm. It can help for sure. I've done it in my team who didn't necessarily know about domain-driven design or any of the particular domain-driven design things. I think the stickies are quite intuitive, so I don't think it was a big barrier of entry to this type of workshop. It does help, and it's especially helpful if you then use domain-driven design and all of these like event-based designs. It does help, but you don't have to. Yeah.
You mentioned that people have a different point of view of the world and how they do things. In the event storm, we know that you have a different speed and different things. So how do you maintain the flow when you have a different background?
Right. So that's why you have a facilitator, because the facilitator should ideally not be like someone that's going to actively work on the system, and they can keep the conversation going in the right direction to be useful. Because of course you can spend like 5 hours debating a really small portion of the system, but if it's not relevant to what you're solving, or if it's not needed for the flow you're mapping or the system you're mapping, it's not necessarily useful. But those types of conversations can definitely surface in an event storm workshop where people will disagree on certain parts, on how they work or how they should work. Those debates will show up. So that's why it's up to the facilitator to sort of navigate things and keep things going. But there should be some sort of clear agenda.
For example, if the requirement change, so how do you, for example, you start working,
Yeah.
and then the client said, I want to do something, and then what is the step?
I mean, that's always going to be something that happens, right? You can always go back to a previous event storm, rearrange the stickies, see where you got it wrong, and update your beliefs based on what the client is saying. You can maybe produce a new event storm if it's a completely new way of looking at the problem. It really depends on how big the change is. But the idea is with designs like this, and that's why practices like DDD are good in my opinion, because they increase modularity, which make it easy to swap out implementations whenever a change arises. Which is why typically something like this, it would be a much better fit for a system which is built with DDD and maybe even event sourcing in mind in particular, because that makes it more resilient to change. Sorry?
Something by
Mm-hmm. So I think the fundamental principle of Agile is to embrace this ever-changing nature of things, which is why I say having modular code, modular design is the way to reduce your model's, how do I put this, the susceptibility to change of your model. So they're not necessarily exclusive in my view. And I see event storming as part of the agile workflow. It's not something that you produce once and never look back or never change. Yeah.
I have one online question for you. Can you read and
How do we convince stakeholders to invest time in it? I mean,
how do we convince the project to invest time in it?
so it depends on who the stakeholders are. If they are product managers or senior leaders of some sort, the idea of having better lines of communication and getting to some sort of reasonable outcome quicker is what I would use as an argument. So the idea that these types of workshops can produce shared understanding quicker and getting to your desired goals quicker, I think should be the main argument. Cool. Thank you.
Nice and sweet.
Okay.
Can I get the mic for a while because
Oh, yeah.
we will have break now. So we have quite significant audience online, probably for the first time. So we will have now break until 8 with the pizza. But before that, Dmitry, come here. So today's event is happening because of this gentleman. It's small thing, but thank you. Thank you for organizing. Thank you very much. Yeah, and it was so long since last event that I forgot to say that if you don't, because we're making pictures, probably you have seen, and probably it's a bit too late, but we have line yards. If you don't want to be share, your photo or face on the socials, just use line yard and we don't post your figure on the socials. Probably it's too late already because I post some pictures, but sorry. Again, it was so late. We didn't organize for a few months, so I forgot few things. Yes. Yeah, probably. But I would have to use your Photoshop skill because mine is crap. Okay, so not overdoing this. There are pizza. Just go grab because it arrived a bit of time ago, so might be a bit cold right now already. So grab.
Okay, so in the previous presentation, the bar is being set a bit too high. I'm probably not going to be able to make it. But first of all, I'm going to make this a bit more unprofessional. If you have any questions, feel free to ask. I don't want it, but you can even cut me off if you are like, if you have a light bulb in your mind. I'm gonna make a bit more technical presentation, and it's gonna be around Flink, this funny rat or squirrel, I don't know whatever you wanna call. Yeah, I think that was a disclaimer. And I realized that I forgot that about me page, so I don't have that slide. I'm gonna just go over quickly. I'm Yusuf. I work in TAE as a software engineer. I work mainly in the card payments, but I also like to work cross teams as well. I'm here for like almost 4 years, and overall I have like 6 years of experience in software engineering. The stuff that I'm going to talk about now is not because I'm a Flink expert, but it's because I think I can capture like a cool story about a company that tries to adapt Flink, and there's nice parts about like the developer experience you can create around. As I said, feel free to ask questions, feel free to deep dive. If I can't explain things, I'm gonna forward it to the Flink official document. So let's start. The problem. So let's do this in the correct way, right? You don't choose the technology, then the problem. You choose the problem, then you choose the technology. You solve problems, you don't finish your technical fantasies. So in TAE, we process millions of payments every day. And by payments, what I mean is card transactions. When you tap your, I don't know, phone into the terminal, it's a payment. And in payment scope, the fraud is like a big problem, because when fraud happens, you lose money, you lose company. So fraud is bad. I don't know if I had to make this disclaimer. Okay, so there's like some things that we detect, and I realize it's a bit hard to read, maybe. Is it? Okay. So we track unusual transaction volumes. So if a guy that's normally selling, small grocery items tries to do like £1 million, yeah, that's fraud, of course. Regional anomalies, because, the TPV is kind of dependent on the country. You have differing transaction volumes based on country. High refund ratios is like refund is when you get your money back, and if the merchant is doing that too much, maybe they are a bit fraudulent. When there's like suspicious payment methods, if you have a guy with terminal that's tries to do like e-commerce transactions, that's a bit of a question mark. Settlement discrepancies and chargeback spikes, they are also kind of identifiers of fraud. So as you see, this is like just a sample, but there are like 6 different fraud signals, and we need to compute them in real time, because if you send money over to a fraudster, you lose the money. So it should be like fast. Why Flink? This is quite a legitimate question, because Flink is not the only solution. Flink is like one of the millions of solutions out there. Before then, we used to write like normal Java Spring Boot applications with Kafka consumers, database connections, etc. Like the classic, what we call as a service. That worked well. That worked for quite some time. We recently started adopting Flink, so it's going to be easy to answer this question. It's because, first, Flink is simple. Flink is a framework. Flink is, if you know what you're doing, it's pretty simple. So in this code example, I have a transaction events, let's say, right? This is just a variable. I'm not talking underneath. Then you union this with refund events, and you do some partitioning over the data stream. If you are familiar with Java streams, this shouldn't be like a weird or alien technology, right? It's like code, 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 and more code. And then you process this. Yeah, standard Java pattern, you just do method chaining. The cool part, this is a bit like iterative over like what I just said. You write and define your business logic, how you process stuff, how you filter stuff, how you map stuff. Then there is this partitioning, the key selection that I'm gonna talk a bit deeper because it's like one of the core things that what makes awesome in my opinion. And you write configuration, like since most of the things are in the framework sense, like you write the configuration, you don't do boilerplate. Okay, this is a strong statement. You do less boilerplate than usual. And inside Flink, you have state, which is the most important part. Like it gives you state out of the box. You don't write data layers, data adapter, database adapters, etc. It's fault tolerant up to some level, right? As I said, you need to configure things to get all of this beautiful good sites. It's scalable in most cases. Like everything I say is like kind of optional, as like in the software engineering, right? Nothing is good or nothing is bad. Everything is great. And in this one, I even like make it explicit. It can do exactly once delivery. It has this semantics, but you need to configure for it. Below, I have like a simple diagram that basically you have like two streams. You can think stream as like a Kafka topic, a RabbitMQQ, or like whatever source you want. Then you filter them, you map them, you union them. So this is like a simple stream join. You process this data coming out, and conditionally, like you send them into a sink. Super common use case is Kafka topic, and Kafka topic here. So it's really common to work with Flink in environment that you read from and you write to Kafka topics. I'm saying a lot of Kafka. This is another one. This is kind of sampling what I described in the business problem, right? You have your source topic, then you have like a small event router that you route things into transactions, refunds, settlements, and chargebacks, like different domain types. And in transactions, you do even more splitting. Then everything goes into processor, and processor has the business logic that it decides if it should sync into Kafka topics. All good up until now? Make sense? Amazing. Because we are getting to the problematic part now. Yeah, okay, let's go with Flink in action. We gonna do like a simple fraud signal pipeline. I know this is like super common example. It's even in the Flink's own website, it's like it's fraud detection. I'm not copying over the same, so. Okay, so this is similar to the code example I showed. We have a variable raw transaction stream, we filter and we map. And the cool thing is like the raw transaction stream, the variable, is a Kafka topic. It's a live object you can imagine. Then we do some pretty logic on top of. We map them into a common data type. So Flink uses a lot of generics. It's not that I'm a favorite, and it's not my favorite to use generics in this level, but yeah, it uses a lot of them. So we map both of the flows into fraud signal events, right? So we can have like a common ground in between. Then in this part, we basically union them. We do partitioning, we do process them. Since I explained this in the example, I'm not going over again. The interesting part is like in the end is if you see like we are mentioning a name and UID. And they are basically, one is for debugging. The name makes it a bit prettier. When you debug stuff, you can understand what you are looking at if you tag them by name. And UID is important when you do state migrations. So when you do changes in your processor, you don't lose the state that exists previously. Yeah, like this part is where it gets deeper because we said state migration. I'm not gonna go deeper in here. Like I want this to be a bit higher level. But if you want, you can see the Flink documents about how state migrations happen and why it's such a big deal that makes Flink like a key component for quite a lot of big companies. And it's like there's a lot of big companies using it. I think Uber is like a big user, and Alibaba is so much of a big user that they had like their internal version of Flink that's quite modified. Next one, yeah, the processor. And yeah, I don't have the animations for this. I forgot, I guess. It's not that complex. As you see, we extend from a keyed process function, which exactly what it says. It's a process function that is keyed. So before using this, we need to do the key by in here. In this process function, we have a process element function that takes an event, has some context object that you can do cool stuff with it, and it has a collector that's depending on your use case that you can send things through. So it's still stream, right? If you want to keep the stream going on, if you want to send stuff down the line, you just use collector to push things out. And as you see here is like in end, we do out.collect and we map the current state object into a model that to be sent down the line. Okay, another cool part, a critical part of the Flink as well, is state here. I'm going to explain a bit more in the next slide, I think, because this cut down to just show the business logic. But literally you have state, you do get state by, like, you get the value of the state, you do modifications, you do update the state, and that's it. Like, you don't need to write anything specific for database. You can choose your provider of how you want to store things. But like by default, if you put this out, it's gonna work. Like you don't need to do any database connections, etc. It's literally just as it is, it works. Okay. I kind of realized that I assume that everyone gonna understand what is a map state, but can you take a guess? Like, what can it be? A map state? No guesses? It's just a map, like the classic Java interface. And in this example, I'm not using map state, right? But I don't have like an event identifier as well when I fetch the state. So how this thing works? It's basically because we did keying. So keying means like you, okay, how much of you are familiar with MapReduce, the Google paper? Okay, amazing. It's literally the reduce part, I think. You have some values that has keys. And when you see the common keys, you forward them into common task manager, common processes. So imagine like this stateful one process only receives key A, B, and E. And like the other one receives only D, A, and Z. This simple logic gives you ability to be able to write code without worrying much about state modifications, because when you write it like this, right? And since you keyed it like this, all of your data that's available into your processor gonna be keyed by a a merchant identifier and a currency. So it simplifies the business logic side a lot because you can cut down a lot of stuff that will be a problem if you don't do keying. And the downside of it is, of course, it's a bit harder to understand if you are not familiar with Flink, because the keying mechanism is kind of a unique thing, in my opinion. Then we have like a little part about state management. I'm not gonna go too deep on top of it. But as you see, we are defining a state configuration. That this one is defined specifically for setting a time to live. And in here, we have 2 hours as duration. And this setup date type, it makes it like if you modify the document, it resets the time. If you don't modify for 2 hours, it deletes it. There is some more configuration to optimize the save points because the states can grow quite huge, sometimes 2 terabytes. And it's important to be mindful about what you store and how long you store, right? With this kind of small tweaks, you can get like big savings. And in the part of acquiring the states, it's also pretty simple. You set a descriptor for your state. It's literally just a unique name for the object you want to use. You set like the setting for TTL, and then only thing you do is like get runtime context.getState, and that will give you a checkpointed state that acts like a normal Java interface. In this case, it's just like a value, but you can have like a map or you can have like a set, etc. That's semantically straightforward to use, but underneath it provides you like a lot of like benefits. Yeah, this is super hard to read because I made it in like the common sense and it's too close to the background, but yeah. So what filling handles? I think I talk about all of it, right? Partitioning, checkpointing, whenever your job fails, and it does fail, believe me, like we're in a cloud environment and stuff dies randomly. And it can do automatic cleanup by itself. Like you don't need to specifically write things into it. There are some edge cases that I wanna talk about that I don't remember how many I write down here. So let's see. Oh yeah, that one is cool one. This one for idempotent event processing. So if you are familiar with event-based, event-based systems, do you need anything? Okay, I'm not sure. Ah, yeah. Sorry, like my screen sharing dies time to time. Is it working now? Okay. Just tell me when it goes down, like. Okay, what I was saying. Ah, yeah. In like event-based system, right? And especially if you are doing like change data capture, you usually have like duplicates. Not in a sense that you consume a single event multiple times, but like there is multiple events that's representing different changes of the data. And of course, as like in our use case, sometimes you don't care about the change and like you just want to skip them. For this, we did like a super dumb solution, to be honest. We have a set of strings that are representing the IDs that we process. And if we solve the ID, we just ignore it. It works. Still works in production, so I guess it's like okay solution. Okay. Yeah, I think that was it. I'm thinking if I had any more things to go. Okay, so eventually we had one edge case. The testing. So this part is more about what we did to embrace Flink in the organization, because up until now I was mostly talking about what is Flink and what is capable of and how to use it. This one is going to be a bit more about like how we adopt it and how we make it easier to work with. So we have a couple problems with Flink. I mentioned that it was using a lot of generics. A lot of generics means runtime problems. Sometimes the code compiles, but it doesn't work when you push data into it. Sometimes serialization is a runtime concern, not a compile time concern. And even in some cases, like you mess up the schema registry and like the Avro models, and like you don't realize when your unit tests are passing, but they actually don't work. So for Flink, you need to do integration tests. Like it's almost non-negotiable. You need the running instance being tested before sending anything to dev or production. Yeah, there's a bit of a challenge, like the Flink is like stateful, asynchronous. You have like a lot of logic in there that might mess up, especially because of generics. That's a bigger problem because it does work on a lot of assumptions, and if one of them is wrong, sometimes your entire job goes down. Sometimes your output depends on your event ordering and timing. That's for more extreme use cases that like you are really concerned about the events and out-of-order events. As I said, this is like much deeper context, so I will suggest you to look into Flink documentation. It has a section about the concepts and it explains the event timing. It's gonna make much more sense than if I try to do it now. And Flink is like a distributed system, right? By design. So how you do integration tests for them? And the answer is not hard. Is actually an ideology that you might already have like in your applications. Is that you don't test Flink, you don't test the technology, you test the behavior. You make it abstract enough that it works with real technology, but like it doesn't depend on what's underneath. In our setup, question? No? Okay. In our setup, we are using test containers that spins up like our dependencies, Kafka and schema registry in this case. Then we have like an integration class space that runs our Flink job and provides some useful tooling like mailboxes that I'm gonna explain a bit more as well. And then, of course, we have our like component that we want to actually test, and the test cases that we have. This is gonna be much easier to understand when we look at the code. Okay, mailbox pattern. I realize this is kind of pointless. It doesn't explain much. So I'm gonna show it to you directly in the test. So in the tests, you declare a company ID. This is like what we use to identify merchants. Then you create a new transaction. This transaction is an e-commerce transaction in success status with like some amount, right? It's like €1,000,000, let's say in this case. And the last one, you send this through Kafka. Of course, we have some synthetic sugaring behind that. When you construct the transaction message, it knows where it to send. It doesn't need explicit declaration. And then for the result, this is the part that the mailbox is cool. You literally say mailbox that inbox cross signals 1, and you drain for this specific key, and it waits for a certain time for this event to arrive. And when it arrives, like you just do validations on top of it. This makes it like tests really readable. Like if I have a new person joining to the team, I can like literally say, okay, go look at the integration test. You will have like an idea about the business logic, at least the important ones. And at the same time, imagine a feature that we want to move away from Flink, or we want to, I don't know, replace with other technology. This test still works, like, because it doesn't use Flink. Like, the only assumption it does is that the application underneath uses Kafka. And as long as that assumption stands, like, this can test anything with the same business logic. There is a pretty cool story of one of my coworkers that he was migrating a Kafka Streams application into Flink. And essentially, he wrote the test in this manner for Kafka Streams. And in the end, like, he didn't need to change anything in the test almost. He just changed in the base to spin up a Flink job instead of Kafka Streams. And the same test worked, same test passed. And with that, he had like he had enough trust in the Flink code base that he can like roll it to production. I think that's it. Yeah, I have this animation that I don't need now. Yeah, this is a bit the background of it. Before every test, we start the dependencies, we register the schemas needed. We set some environment variables depending on the test case. Of course, if you are testing something that is out of normal, sometimes you need to mess with these. You kickstart the Flink job and you clear the mailbox to have like a clean start. And that's just it. It's like a lot of syntax sugar in behind, but to be honest, it's like super pleasant to read in my opinion. Way it works, exactly what I said. I'm skipping that part. The trade-offs, they are slow, of course. They require Docker. That's I have problems time to time. My Mac is a bit old. I'm calling out to replace my PC. Flaky if timeouts are too short, and it's resource intensive in the same as like requires Docker. So this is like our idea in general. Unit test the processors directly, integration test the full pipeline. Because like for unit level, you don't need that much setup, and probably you need to test more edge cases that it's not worth to create like 10 integration tests. This part I'm gonna skip a bit fast. For local, we just use Docker Compose, and you can run your job in this way, but also you can put it as like a Docker Compose component as well. For Kubernetes deployment, Teya is running on cloud mostly, and we have our own Kubernetes deployment with like, it's mostly provision. And to make the switching to Flink easier, to make people more comfortable, we created a custom Helm chart. It's more or less like a wrapper on top of the official one. It contains a bit more defaults and opinions, let's say in this way. In here, you basically define what is the version you want, the state backend that you want, availability types. You define the resources that you want. This is important because to handle more load, you need more resources. And there's like upgrade modes that's in save point in this example. I forgot like what was the other one, but like again, you can look at the documentation. The same Helm chart also provides you like production alerting. So you can define what Slack channels that you want to be alerted on, and we use Opsgenie, which Opsgenie teams that you want to alert when something goes wrong. And in the Prometheus rules, like you can define what you want to alert on. Of course, this part is truncated just to the names, but like you define what is the alert premise, right? For managing configuration, we use like a straightforward solution. Have a properties class, get environment or default, and set all of them into configuration. This code example is shortened a bit too much because it's like long by its nature. But yeah. Yeah, that one is like, I don't remember why I put this, but of course, we don't change anything in between environments. In your local dev or production, the same code runs, only difference is like you change the configuration. As an example, you don't run as big machines as in production in dev. So another really cool thing that we did is creating a cloud code skill for Flink. I will say it's pretty useful when you need like a second pair of eyes to check stuff. Because like personally, I miss a lot of stuff time to time, and this helps a lot. Yeah, exactly. Like when you do something dumb, it tells you. And all of the things that I explained, we packed it into a single repository, a single template. That in the internal developer portal, you can just say like, choose this action and like create a new service. And I think like our speed to put stuff in production right now is like less than a week, maybe 2 or 3 days. Over this time, what we learned, build a template, it makes life easier, it makes easier to distribute good practices and bad practices. That's the downside. But yeah, it's like you need to test like how you deploy. Like you need to have this proper integration test and proper environment. So like you are comfortable with what you are deploying, right? I don't think anybody is like comfortable deploying stuff that doesn't work in dev to production. Yeah, about mailbox. This is an important one. It's not about Flink. It's about in general in engineering. When you do something, monitor it. When you do changes, monitor it. Be aware of it. Set alerts. Have nice shiny Grafana dashboards. Not just that you brag about them, but like they are actually really useful. If there's like weird patterns, you can catch them like quite easily. And yeah, I mean, the context of like the entire slides is like Flink in this case makes it easy to develop this kind of stream processing faster and reliable, and like it gives you enough of a framework that you actually don't spend much time on the technology, but you deal with the business. Yeah, I guess that was it. If you want to give feedback, you can give it through this QR. It's anonymous, so you can like say whatever you want. Yeah. If any questions, I can take. Yes, please. The mailbox. Yeah. I can share like a better looking one because that one was cropped out a lot to be able to fit into the slide. Yeah, but I can show you. Yes. Exactly. It gives you this kind of capabilities out of the box. Like in a higher level, you can think it as like, you know, in JavaScript, when you use like Express.js, you don't write HTTP protocol from ground up every time. It's like in a similar sense, like it gives you enough good defaults that you don't deal with technical sides much. Mhm. Exactly. Yeah, I mean, it kind of answers itself. Like, Flink is the framework that you use for different types of data inputs and outputs. So I explain all of it through Kafka, but like you can connect a RabbitMQ as an input, then you give output as like an S3 file in like I don't know, in like batches, etc. It's much more flexible than what I explained, and I think I just managed to scratch the surface of Flink. I would really suggest to take a look at their documentation, because also another thing is all of these examples that I give right in the code, if I can get back to it. Yeah, this part. So like the state processors, etc. This is specific to data stream API. It's like a section under Flink. But Flink also gives you opportunity to write raw SQL. So you can write SQL to do all of this stuff. It's of course higher level, less control, but at the same time, it might be like a better fit for use case. Like as I said, this is like super broad. I just managed to scratch the surface a bit. Any more questions? I don't have an easy way to skip slides. If no questions, here's my LinkedIn if you would like to connect. And I hope the QR works, I'm not sure. Yeah, go ahead, please.
As you guys were using Kafka, so what made you guys choose this is the Flink inside other
So we had Kafka streams and like normal Spring Boot application that reads Kafka, writes to Kafka, etc. For the Spring Boot application, I can say the problem was it was too much boilerplate and like you duplicate thousands lines in every repository. It was not optimal, to be honest. For Kafka streams, it's area that I'm not that comfortable to talk about. But I think the main problem was how it does the same thing that Flink does with like less practicality. So like to have the same state benefits, to have like the same input output simple logic, you need to delve into more into infra and do a bit more messy work, let's say. In the Flink side, it was a bit more of a black box that you can rely. But again, like this is not a comparison that I will do comfortably because I don't know the Kafka stream side that much. Sorry? It's cheap in this sense. We use AWS. AWS provided Kafka. I'm trying to remember its name. I think it's called Mask. And in that, I think you get charged on top of the Kafka partitions that you have. And one problem you have with Kafka streams is like it creates a lot of partitions and new topics, like temporary topics. And that was a reason why we choose Flink as well. Like it was a bit costly because of this reason, using Kafka streams. Yeah, so basically in the cloud side, you have a Kafka Flink operator. It's kind of out of the box. It's quite straightforward to put it working. And after that, you just need to have a middle component that submits jobs into that process. I mean, it sounds complex when I talk about it, but it's quite standardized flow. So if you look at documentation, you can see that how they support Kubernetes deployments. I'm not sure how much it took us to add support for Flink in our cloud environment, but it was not a quarter. I think it was less than 3 months.
One question online.
Yep.
How do you manage state per user or per order?
So do you want me to repeat with more sound? Okay, so the question is like how we manage the states. Is it per store or per order? We do it per store because like in this use case, our goal is to mark fraudsters, and fraudsters are per store. Like you don't have a case that you have a single order fraudulent and like the rest is fine. It's usually when something is fraudulent, it's like all the transactions. So, but that's an implementation detail, let's say. If there is no more questions, thank you so much. I wish I put like a link to the Flink documentation because I said Flink documentation like 10 times in the slides.
Next time.
Yeah, next time, hopefully. Yeah, that's
Hey.
it.
Yeah, thank you, Yusuf.
Yep, let me take this out.
So I will take part. The first announcement is that we can skip a bit of time. We go into the pub, we don't know yet what pub. So if you want to join, just wait for us somewhere. But we definitely will find some